Hello students, welcome to Sarasa classes. Now in this particular lecture we'll do something very vital. What is it? How to calculate bond order in molecules. Okay, this is our topic today. So I will take a very simple example. I'll take the resonating structures of ozone, and there will be two of them. Okay, so what is the resonance hybrid? The resonance hybrid will be this structure in which the electrons are completely delocalized over all the atoms, and we will say this bond length is equal to this bond length. Okay, but if you look at the resonance structures 1 and 2, you will feel that this bond is going to have less length than this bond because it is a single bond. But in reality, these 1 and 2 are the resonating structures or canonical forms. The actual structure for the ozone is the one shown below. Now, how to calculate bond order for this molecule? So the formula that we will use is going to be number of bonds, okay, divided by number of resonating structures. Now when I say number of bonds, what do I actually mean over here? Please understand, over here we will choose one particular bond in a molecule or in the resonating structure. Say I'm choosing this two atoms and I see that there is only one coordinate bond over here. Again, I will choose in the other resonating structure these two oxygen atoms, and then I will find how many bonds are there. I will say 2. So in total, for these two resonating structures, the number of bonds between these two atoms which are highlighted, we will say it is 3. What is the number of resonating structures? 2. So what should be our answer? 1.5. Okay. Now let us apply this again. Now let us take another example, which is obviously over here we are saying it is a nitrite ion. So for a nitrite ion, we will be having the following structure. All right. And so the two resonating structures for the nitrite ion will be as follows. And again, just like for the ozone, we can see there are two resonating or canonical structures. And if we choose two such atoms, we will say what is the bond order. Again, we use the same formula. And if we say what is the number of bonds between two atoms from all the resonating structures, it will be 3 divided by 2. So it is going to be again 1.5. Let us choose another one. Now let's say we are doing for the nitrate now. So for nitrate, what is the structure? We know it is this one. What are the resonating structures of the nitrate? So we will say these are the ones that are possible. Now here we have a N double bond O, and we can have, so in total we are seeing that there are 4 resonating structures over here. Okay, so sorry, not 4 resonating structures, 3 resonating structures. And if we choose 2 such atoms, so let's choose this one and that one, then we choose this one. What we will find for our bond order calculation, the number of bonds, we will say 4. How many resonating structures? Obviously 1, 2, 3. So 4 divided by 3, and so the bond order will be 1.33. Okay, so that is what we have to say. Again, let's take another example. Suppose I have given ClO4 minus. So for a ClO4 minus, we know the structure is something like that. Okay, and if we now think of the possible resonating structures, very easy way of doing it is using arrows like this. Okay, which I have not shown in the previous ones. So now this will become a double bond, that becomes a single bond. What you could do is make this double bond, open this one up now, and you get the next resonating structure. Again, close this one up, open this one up. So what we can see over here is there are in total 4 resonating structures for the perchlorate ion, right? So again, if we do the bond order calculation, what we can say, if we choose one such bond, suppose this one I have chosen. So if we take all the resonating structures and the number of bonds between Cl and O, so we will say there is over here in total 7 bonds, and now number of resonating structures obviously 1, 2, 3 and 4. So that should be divided by 4 and your answer should be 1.75. Alright. Let's take another example. Suppose we are doing this now for the phosphate ion. For a phosphate ion, this is one of the resonating structures. Now to get the others, think this is closing and becoming a double bond. So we will have a double bond here and a single bond there, single bond here and a single bond here. Now let's think another possibility in which this is going in and that is going out like that. So the other resonating structure will be obviously double bond here. Now you think this one becomes a double bond and that one opens up, and similarly we will say here also we are getting 4 resonating structures. Choose any of the oxygens and the phosphorus atom. So if I have chosen this one, this one, this one and this one like that, I can already see 1, 2, 3 and over here we have 2 more bonds. So in total there are 5. So we will say bond order is going to be 5 by 4 and our answer would be 1.25. Okay. Let's take another one. Say we have been given chlorate, which is ClO3 minus. Now for that we know the structure is somewhat like that. This position being taken up by a lone pair. So we'll not show these lone pairs in the resonating structures. We can just use two dots like that, maybe. Okay. Now if this one forms the double bond, we will open up this double bond. Okay, that is how things will happen over here. Similarly, we will say that one closes up, this one opens up. So if we now want to find the bond order, we will choose one such bond like that. So again, for bond order calculation, we will say from here 2, 2, and here 1, so it is 5. Number of resonating structures is 3. So if you divide 5 by 3, we get 1.66, and that should be our bond order for chlorate. What about ClO2 minus? Again, the resonating structure, these are your two lone pairs. Okay, so again we will use the Lewis dots to represent lone pairs, and as we can see over here, so the resonating structure, the other resonating structure will be what? This is the other resonating structure. Okay, so now again if you choose the bonds, what will we say? This is very much similar to your NO2 minus or ozone. So if you do the bond order calculation, again your answer will be 3 by 2, that is 1.5. Okay, few more other structures that one can try are BrO3 minus, IO3 minus, XeO6 4 minus. So these are some other structures or molecules that you can try. Now, one important part over here that I wanted to discuss, which is the partial charge in the resonance hybrid. So the resonance hybrid for ClO2 minus will obviously be looking something like that. Now see, this is a mononegative molecule, and since the charge is being distributed on both the oxygens, so this one will have minus half delta charge, okay, and this too also will have minus half delta charge on it. Okay, or we can simply say minus half charge on oxygen and minus half charge on the other oxygen. What about for the case of ClO3 minus? Now out here again we will say that the charge is delocalized over 3 oxygen atoms, and since the charge is again mononegative, distributed over 3 atoms, just like that. So obviously here the charge will be 1 by 3 minus 1 by 3 minus 1 by 3 for each of the atoms. Again, for the phosphate ion, what we will say? Okay, we will say for the phosphate ion, charge over here is -3, right? And that is being distributed over 4 oxygen atoms. Okay, so over here it will be -3 by 4, -3 by 4, -3 by 4, -3 by 4. For a perchlorate, now this resonance hybrid is actually indicating that all the bonds in the perchlorate are of equal length. What is the charge? It is mononegative, distributed over 4 oxygen atoms, right? So over here it will be -1 by 4, -1 by 4, -1 by 4, -1 by 4. Okay, so that is how we will be calculating the bond order for the molecules. And like I said, that few more examples that you can practice are sulfate and practice sulfite. Okay, or you can also practice the PO3 3-, okay, as a homework. Thanks for listening and have a great day.